So the first one, I want to determine the amplitude midline and whether it has a reflection or vertical shift. So what I'm going to do first is look at the max value is 3 and the minimum value is -1. So halfway between that is 1. So I'm going to identify the midline of my here. And then I have a max here and the mid like that. And then I get through one period when I go back to that midline in 2 pi radians. And so to me that looks like, if I look at this equation here, it looks like a sine function because it goes through the midline at the endpoints in the middle. And I could do that as a sine function that's upside down. So so let's see here. So does it have an x-axis reflection? I'm going to say yes in the way that I'm looking at this. The period, I can see that it completes one period in 2 pi radians. And the midline is y equals 1. The vertical shift, it's shifted up 1 unit. And the amplitude from the midline to the maximum is a length of 2 units. And so that is my amplitude. And so a possible equation for this graph would be y equals -2 sine of x. I guess we can use x. And then I want to do +1 because it's shifted up 1. Okay. The next one says a mill has a water wheel that has a radius of 13 feet. And the bottom of the wheel is 1 foot above the surface of the water. The wheel rotates counterclockwise starting at 3 o'clock. Let h be the height of a point P above the water as a function of the angle of theta radians. Find a formula for h of theta and sketch a graph from 0 to 2 pi radians. Okay, so I can see that the minimum value of P, the minimum height above the water, when it's at the very bottom, it says that the bottom of the wheel is 1 foot above the surface of the water. So the minimum height is 1 foot. And what's the maximum height? Well, from the surface of the water, so h is the height in feet above the water. And so, so we have the 1 foot above the water plus 13 feet for the radius, plus 13 feet for the other radius. So the tallest point, or the maximum height, is going to be 14 feet. Okay? And sorry, not 14, excuse me. So it's going to be 13 plus 13 plus 1. So that's 27 feet, excuse me. Feet. And so I want to do the height. So the it's starting out at the 3 o'clock position, and that is at a height of 14 feet. And then as it goes up here to pi over 4 radians, the height now is the maximum height, which is 27. And then when I am at pi over 2 was the previous, excuse me, pi over 2. And then when I am at, so this is pi over 2 at the max, and this is pi radians. When I'm at pi radians, the height goes back to 14 feet. And then when I am at 3 pi over 2 radians, down here at the bottom, the height of my point is 1 foot above the water. And then when I get all the way to 2 pi, all the way back around, my height goes back to the height I started with, which was 14 feet above the water. So here's a graph of that sine function. I can see the period hasn't changed. It's just a period of 2 pi. And we can see that since we're rotating counterclockwise, it looks like it's going up first and then down. So it looks like a regular sine function. But what we can see is that the amplitude and the midline have changed. So we'll have h of theta is equal to, so what is my amplitude? My amplitude is, from the midline, it goes up 13 and down 13. So my amplitude is 13 sine of, and then again my period didn't change, so sine of theta. And then I want to do plus, and it looks like it's been shifted up 14 units. Okay. The next one, I'm asked to find a possible formula for the trigonometric function shown at the right. And so what I can do then is, the first thing I like to do is I like to kind of put a box around where everything is and try to figure out, so I'm going to put a box maybe like this around one period of my function. And so what it looks like to me is that this is an upside down cosine function. And if a quarter of the way through is 4 pi, then that means that halfway is 8 pi, and here would be 12 pi, and then one period would happen in 16 pi. So the period is equal to 16 pi for this. I can see that my midline has shifted up, so the vertical shift. My midline has shifted up 5 units. And then if the minimum is at 0, then that means the maximum is going to be, I take that distance from 0 to the midline, which is 5, and I'd add 5 more, so that's 10. So my amplitude is 5. And I think that's all. And we notice that it's a cosine graph that has been reflected over the x-axis. Because it starts at the minimum and then goes up. And so, all right, so I think I'm ready to write out what this is. So so if the period is 16 pi, that's 2 pi over, so what I want to say is that y is equal to a cosine bx plus c. And so the period is 2 pi over b. And so if I multiply b on that side, I get 16 pi times b is equal to 2 pi. So I can divide that by 16 pi. I'm going to get b is equal to 1/8. And then a will be -5 cosine 1/8 x plus, and then I've shifted up 5. So that's my possible formula for my trigonometric function. Okay, the next one says a population of animals oscillates between a low of 1,300 on January 1st and a high of 2,200 on July 1st. So I can label the months there, and I can see that July 1st is at 6, and so I can put the max there and the min here. And I'm assuming that it's modeled by a sinusoidal function. So if that's the case, then the midline would be halfway through there, and it would hit that midline halfway between 0 and 6, which is at 3. So I can go ahead and kind of sketch that out. All right, and so I want to find a formula for a population P in terms of time, in terms of the time T in months. Okay, so one thing I might notice is that I've only drawn half of my period here, at 9 months and then at 12 months. At 9 months it'll go back down to the midline, and then at 12 months it'll be at the minimum. So I can see here that this is an upside down cosine function. That's been reflected, or a cosine function that's been reflected over the x-axis, and then it's been shifted some more. I can see that the period is 12, and I can see that the amplitude, the amplitude will be halfway. Let's see, if I do 2,200 minus 1,300, that's 900. If I divide that by 2, it's 450. So it's up 450 and down, and that's 450. So halfway, so 1,300 plus 450 is 1,750 would be this midline. Okay, and so the amplitude is 450, and the vertical shift is up by 1,750. Okay, and so I think we're ready to write it down now. So I need to find, so we're going to do y is equal to a cosine bx plus c. Okay, so the a I can see is going to be a negative 450 cosine of, okay, the b is related to the period. So I know the period is equal to 2 pi over b, the regular period over b. So I can set that equal to 12. So I can see that b is equal to 2 pi divided by 12, which is pi over 6. And then my vertical shift is up 1,750. Okay, and so this is my equation there.